Okay, so hello and welcome to my talk. Uh, the title is Move Your Java Backend to a New Level by Adding Kotlin to the Mix. Okay, so maybe let's just try to be active. How many of you are already using Kotlin? Do we have such people here? Oh, quite a lot. So I don't know why you're here actually, because because you already know why you're doing it. But maybe you have some people around you who might use the information from this talk. And how many of you are using Java and think you don't need Kotlin? Okay, we have some opportunity for some discussion. Okay, that's nice. And here in the bottom left corner, there's a QR code with a link. That link can be useful to you because when I was preparing for this talk, of course, I collected much more resources and information than I can present here within the limited time. But I didn't want to throw it away, so I created some kind of a mini ebook that's like an extended version of this talk that you can download for free. And also the second reason why this can be useful, I don't know about you, but when I go to some talks, when there's a time for questions, either there's none, or if there is a time for question, I usually, many times I don't come up with any like reasonable questions, just stupid ones. And then a day or two later, then I have some good questions, but of course it's too late. So this is also a way to keep in touch and continue the discussion. Who am I? My name is Marian, and I like to say I love to integrate. One of the things that I do right now, I'm writing a book about integrating and connecting systems via APIs. But that's just one way of connecting. And usually when we connect systems, we can have different reasons, but one common reason is that there is some legacy system. Who likes legacy systems? Okay, but legacy systems are very important because they have usually a lot of business value, and they usually make the most money, of course. So if you want to be paid well, you need to take care of legacy systems as well. But of course also the world is evolving, and we also need some modern stuff. And the best way to get the best of the two worlds is to try to connect them, to integrate them somehow. And I think Kotlin is also some tool that can help you join the legacy of Java with some cool new stuff. And what I also like is not just connecting systems, I also like connecting people, because when developing software, we don't only need coders, we also need some other people who don't code or don't know how to code or don't understand what coding is about, and we need to somehow work together, and we need to be able to communicate. So that's also very important. And also in the tech community, we can have some sub-communities, and it's important that these sub-communities are able to talk together and understand each other, at least to some degree. So this talk is also my contribution to joining a little bit the Java community with the Kotlin community. Okay, enough from this introduction. And the last thing, why I'm actually here, why I'm doing this. To best describe my motivation, I will tell you a little bit of my story. And as you can see from my t-shirt, I am a Java guy. I'm at the Java user group, so yes, I should be. And I think I will always be one. So I started programming in Java when it was still at version 1.0 something. And throughout my whole career, I've always done something connected to Java, or at least Java ecosystem. And in 2016, I got the opportunity to program for Android, and at that time we used Java, which was quite common at that time. Unfortunately, the Java used for Android was a little bit limited because it's a little bit different runtime. So basically we had to use the syntax of Java 6. Although at that time, of course, from the backend development, I already knew Java 8, which was the new cool thing at that time. And I was a little bit sad about that. And for example, if we had to wanted to share some code between Android and backend, we had to stick to this Java 6 syntax, which wasn't very cool. Then later, around 2017, maybe beginning 18, I sometimes saw some examples of Android code which wasn't in Java. It was in some new language to me. I didn't know what it was. Then I learned that it was named Kotlin. Actually, exactly at 2016, the first version of Kotlin was released, but at that time I didn't know about it. And okay, so I didn't quite understand, but okay, roughly I understood what the code is about, but I didn't understand why it's there. And yeah, of course, I learned that Google decided to use it instead of switching to a newer Java, and then maybe again to a newer Java, and again to a newer Java. They just said, okay, now we will use as a default some new language called Kotlin. Then, interestingly enough, after this project I switched to another one where I worked on the backend, but it was based on Spring Boot, but it wasn't in Java, it was in Kotlin. And that's now I thought, okay, maybe this Kotlin thing is not just some extravaganza made up by Google, as they like to do, that they are trying to force the whole world to use. Maybe it makes sense to use it also where you have other options. And I had to learn this language, which was quite quick for a Java programmer. It took a few weeks maybe to start using the syntax, then maybe a few pull requests more to really get rid of some Java-isms and start to write really idiomatic Kotlin code. And what's for sure, I fell in love with the language. And then I switched projects again, and I had to face the reality, which is that Java is much more widespread than Kotlin, which means also there are much more Java projects and teams than Kotlin ones. Here also, when we compare year by year, we can see that it's quite similar. Although I don't want to be a prognostic, but yeah, someone could say that the gap is getting a little bit slowly smaller. But another view, if we zoom in, we can see if we compare Kotlin to other JVM languages, which have been around for longer, we can see that Kotlin has overtaken them, and it is in this context it's really an important player. Uh, okay, and then now I'm still using Kotlin for my hobby projects, but for the customer projects I got back to Java. But I started seeing that there are some new Java versions coming which bring some features that are somehow similar to what I knew from Kotlin. And yeah, I started to be very eager about upgrading Java to these new versions. I had one project where I tried to upgrade Java to Java 17, and after I created the great nice skeleton of the new project, then I learned that actually it's not supported by that organization because they still don't have their CI/CD pipelines ready and so on. So I had to downgrade to Java 11, but okay, at least I tried. And I think this situation is quite known in the Java community right now. Yeah, I shouldn't even say LTS version, but it's there are de facto LTS versions. The latest one being Java 21, where we have the great virtual threads, for example. But many projects are lagging behind and not using even the latest LTS version, not to say the really latest version, which is right now it's 23, right? Or yeah, it will be 24 very soon. Okay, now I said that I like to connect people, and I thought maybe also the reason why Kotlin is not used so much, or not as much as it would deserve, is that there are people who don't have enough information and don't know why it's worth trying. So I said, okay, let's try to do something about that. And that's basically why I created this talk. And if you have children, you may know this situation that the child doesn't want to eat some food, and you ask, but have you tried it? And the child says, no, I haven't, but I know I don't like it. And that's basically the point of this talk, that you can't really tell if you like something or if something is useful for you if you haven't tried it. So you should at least give it some time and see the real potential, or if it's really not something you want. Now, I mentioned people who are not coders. Do we have such people here? Do we have somebody who does other work than writing code or reviewing code? Oh, great, nice. Yeah, but even for the others, I guess you meet such people at work, and they are, as I said, they are very important, because those are the guys who hold the money. So if you do something for them, they might be willing to do something for you, which might be good. And the things that the non-coders at Java at software projects care about are deadlines and budgets. And there are, of course, many factors that contribute to meeting deadlines and being within budgets, but one thing that we should strive for is efficiency and productivity. But what's often forgotten, it's not just be productive, whatever it takes. We want it to be long-term sustainable. So if we start producing a lot of features, and but the code that we produce is such low quality that suddenly when we start testing, we see that there are a lot of bugs, or if we need, with every new feature that we need to add to the project, the productivity actually starts dropping because nobody understands the code, and every time you need to change something, you need to refactor for other things, and you are actually afraid to change anything because you don't know what will break. Then of course that's not the kind of productivity we want. And again, how to achieve long-term productivity or efficiency of coding? Again, there are many factors to it, but one of them is code quality, in my opinion, and also the motivation. The people should be motivated. If the people are not motivated, of course, they will pretend they are delivering a lot of features, but it will be low quality. So now the big question: can you give me some ideas what do you imagine when somebody says quality code? What traits should it have? Any ideas? Well tested. Great.
It should work.
Okay. But not just once, right? And not just on your computer, also on the production, right? Any other idea? Something like
only one person, but more person can know what's inside for a long period of time.
Readability.
Yeah, great. Yeah. If you go to some interviews, you sometimes get the question, do you know the solid principles? Do you think solid principles are important? They may be, but there's one thing about solid, that it's designed for object-oriented programming, and not all code nowadays is actually object-oriented. So that's also something that you can answer when somebody asks you at interviews. But let's get further. Okay. In my opinion, one thing that's how you can really describe quality code very shortly is that it's short and expressive. That means it's not longer than necessary, so that you don't have to read stuff that's not important, and still you understand what the code does. Or in other words, it has a high signal over noise ratio. So there's a lot of parts in the code that bear some signal, that give you some information, and small part, only a small part of the code is just, some brackets or some things that you don't really care about. Here's a notorious example of low signal over noise ratio. This is a typical Java bean, where actually the useful information is here in this rectangle, and all the other stuff is just boilerplate code: getters, setters, toString, hash code. And okay, now you probably say to yourself, I have probably forgotten about Java records, right? No, I haven't. I know that Java records have been in Java since Java 14. And yes, they are great. That's why I tried to upgrade to the Java 17 at that project. And they are actually something that's very similar to a Kotlin feature called data class. But there are, we could say, okay, problem solved, but is it really so? do you think we can? Do you know of some cases where you cannot just take any Java bean and convert it to a Java record? Any ideas?
Some logic. Well, it has some logic. Also,
Logic.
because,
Where can you put logic in a record?
Records are final.
Yes. So if it cannot be final, for example, in JPA, where it says you have to have setters, yes. Another reason, for example, if you use a dependency injection, like for example Spring Boot, by default, and also if you use some annotations, there are some proxies generated, and these proxies need to subclass your bean. So again, record is a final class, so it wouldn't work. You would have to use some other mechanism. And another, yeah, of course, there are still projects that are so old that the Java doesn't have records. But of course, yeah, the first thing you should do is to upgrade. But still, it happens. And with so here are these cases. With Kotlin, we this is more flexible, because with data class you can these elements or fields can be either val, which means read only, like in the record, so they are immutable, but you can also make them var, which means they are you can modify them. So that's one thing. Another thing, by default, all classes in Kotlin are like final in Java, so they are closed. You can't subclass them, but you can open them, and then you can subclass them. So again, you still have the concise constructor and other cool like automatic getters and setters, but you can also do other things. And another thing that you can see in a lot of Java projects, that they use the Lombok framework. How many of you don't use Lombok framework? Okay. Yeah, and why? Do you have any reasons for it?
Short, it's evil.
to install some IDEA plugins to fully see the code.
Yeah.
Because it's say compilation errors and stuff like that.
Yeah.
Because it's missing the setters and getters.
Exactly. So with Kotlin, basically it's a annotation processor. So you put some annotations to your class, and some code is generated based on them. Like, for example, also with Mapstruct. But the difference between Lombok and Mapstruct is that with Mapstruct, you write an interface, and based on the annotations, an implementation of the interface is generated, which is a separate class file, and that is pretty standard. But with Lombok, the generated code basically replaces the same class in place, and that's the evil. That's the biggest evil that I see in it, because basically now the bytecode doesn't actually correspond to the source code, to the Java source code. So as said, you need some so all the tools that you use have to know about this, and they have to understand. So IDEs, debuggers, whatever, they need to understand that the code will be different than the source code, and also this means basically that you are not really writing Java code anymore. You are writing code in some new language called Lombok Java, and this Lombok Java depends not only on the version of Java but also on the version of Lombok. So now you have a double dependency, and of course we know that the more dependencies you have in your project, the more combinations are possible of what the result can be from that, and of course the higher chance that something will not work as expected, and there will be some really nasty problems that you will spend a lot of time fixing or investigating actually. So yeah, that's why I also don't like Lombok. And yeah, but so the idea is, if we are already using some new language that I named Lombok Java, we could instead use some properly defined language which has a really better support and a bigger community, and that would be Kotlin, of course. Now there's more to using records in Java. For example, if you it's quite easy that the number of fields in your record can grow, and if you here we have only 4 records, 4 fields, and already it's getting a little bit hard to read, because now the IDE starts to help us. Okay, here is last name with double A, so that we know which constructor parameter is what. Again, in Kotlin, very subtle feature but very useful one, named parameters. So now you don't have to preserve the order of arguments, and it's totally clear which argument is what. Another great feature, many times, records are immutable, which is, I don't want to say it's bad, it's actually very good. Wherever you can, you should use immutable data structures. But that also means if there is a business case that you need to modify something, you need to create a new instance, a new copy of your record, and that means you have to again copy all the fields, including those ones that you're not interested in or that are not changed. In Kotlin we have this copy method or constructor where you only specify what's changed, and it's very readable and very concise. Another great thing in Kotlin is that there are default values for arguments, not only in constructors, also for any method or function, which means if there something is usually false, then you can say it this way, and you don't have to write I don't know how many overloaded versions of that method, and basically again writing a lot of boilerplate code that nobody needs. Okay, so that was like some first bite of what Kotlin can bring us. And again, back to Java. To convince you that I am a Java guy. In the 90s, what I really liked, what attracted me to Java, was this principle of making the common things easy and the uncommon things possible. So in the 90s, Java was great because that was a language that had a garbage collector, so you didn't have to manage your memory like in C++. You didn't have it automatically contained support for Unicode, so for Czech and Slovak text you didn't have to use some special libraries and hacks. It had threads, so you could have parallelism. It even supported TCP/IP in Windows, which was at the time really a new thing in Windows, and it was based on the idea that everybody wants to do object-oriented programming, which was probably true in the 90s, but yeah, I have to say that I am a little bit maybe unfair to Java, because Kotlin is 20 years younger than Java, and of course world changes, and what is considered common also changes, and today not everything is object oriented, and we also know some other paradigms, and especially interesting is the functional or data-oriented programming, which is a little bit different from object-oriented. Now, of course, Java also started to react to this trend with Java 8, where we got streams and lambdas, function method references, and so on. But already by that time Java was a mature language, and of course Java tries very hard to be backwards compatible, so it had to be added so that it is still compatible with the existing code, and Kotlin didn't have to do that. Just a small note on side, even Java is not always backwards compatible when we speak about syntax. As a small example, the underscore. Before Java 8, it was like admissible as a normal identifier. You could have a normal variable called underscore, which would be strange, but somebody might think it's a good idea. And then it was forbidden completely. And from Java 22, we have a new use for it. So-called unnamed variables. So if you have, for example, pattern matching, where you have a lot of you have a record with a lot of components, but you are not interested in all of them, you can replace all the ones that you don't need by underscore. So you can have like 2 or 3 underscores, and it will not cause any name clash, because it means it's an unnamed variable that you don't want to use. So here we can see that even in Java we have some things that are deprecated and then maybe are changed. On the other hand, if we look at Kotlin and functional programming, of course the most important in function programming are functions. And Kotlin really makes the functions the first-class citizens. So in Java, if you have really function like functions from mathematics, it's just something that takes some inputs and produces some output. You can't do it. You can't have a standalone function. It has to be a method inside the class. So, for example, this is you see it in many utility classes, that you have a function that does something useful, and it is a static method inside the class. And now you need every time you need such a utility function, you have to think, okay, so was it utils or util, utility or helper? Where is it? What if I have one utility in one class, another one in another class? Now should I merge them? How will it break my code? Whatever. So this is just something that is not necessary. It's just because somebody said that everything should be inside the class. On the other hand, in Kotlin you can have just function outside of any class. what's more, you can even define so-called extension functions, which means you can pretend to extend a class that's totally out of your control, for example string, and then every time you write the syntax to invoke such a method of that class, it will go to your extension class, and this is very, very useful in many cases. Of course, you need to be careful because sometimes you could create some clashes, but you can also do it within some scope, within a class or within even another function or whatever. Now, the typical pattern for functional programming or data-oriented programming is some kind of a pipeline where a stream of data is entering, and then you do some filtering, mapping, aggregation, and then you collect the results somewhere. So with of course, quite often we do that with collections where we have where we can have multiple items, multiple pieces of data, and the typical pattern for this most commonly used way for streams is that we write some collection dot stream, then we do filter, map, whatever we need, and at the end we write collect something or to list or something. And with Kotlin, this is already thought about before. We don't that this is the most common use case. So by default it automatically all the collections have the map and filter and other such second order functions directly in their interface, so you don't need to convert them to stream first. And by default the result is again automatically a list or some other collection, so you don't have to explicitly collect them, which makes it much nicer, because when you do it 95% of the time, then why should you always explicitly say that you're converting to stream and collecting? And another nice thing is the lambdas in Kotlin. If a second order function like filter has just one argument, and that argument is a lambda, then you don't have to write the round brackets. You just start with the braces. You don't even have to specify the argument name. You can use the implicit argument name that's called it, and this makes the code again much more concise and much more readable. You can immediately see what's being done here. Again, functional programming is complemented with immutability, because we want to make sure that if we do something in parallel, that the threads cannot overwrite data. So that's why we try to make the data immutable. With Java, of course, we also have immutable collections. We have list of. But again, for backwards compatibility, the interfaces are still the old ones, which always contain, for example, add. So even if you have a immutable collection or unmodifiable collection, you still are able to write some add or delete at least at compile time, and of course at runtime you will get an exception. In Kotlin, this is again anticipated, and there are like separated interfaces for immutable collections and mutable collections. So if you create an immutable collection, it doesn't even contain a method called add. So you will see you have a mistake in compile time, which is of course a great help. And yes, of course you can ask for a mutable collection, and in that case you will get a mutable collection, but the implementation, it will be chosen by the library based on the number of items, because again, most of the time we don't care about the implementation, we just want something that's mutable. Of course we still have access to Java classes, so we can say explicitly I want an array list, but most of the time we don't want to do that. And here I guess everybody knows the term $1 billion mistake. That's something that happened a long time ago in 1965, and via various languages it got to Java. And basically it means that if we have a reference type, so basically a class or an array, anything except primitive types, we can always assign a null to such a reference type. And of course that's the source of the notorious null pointer exceptions. And yeah, we have some remedies for it in Java. We have the optional, we have various non-null annotations. Unfortunately, yeah, with optional, nobody prevents your function that has an optional return type from returning a null. So, well, that can happen. Again, if you use annotations, nobody guarantees that these annotations will really be respected, because you need some either annotation processors or some libraries that will check these annotations, and there can be even different annotations from different libraries, so they can be inconsistent. And yeah, well, again, it's an afterthought, and it's not, the solutions are all imperfect. On the other hand, in Kotlin, by default, all types are non-null. So if you have something of type string, you cannot assign null to such a variable. If you want to have nullability, you have to explicitly say it by adding the question mark after the type name. And in that case, you can't just call a method or access some field without any handling. That will cause a compile time error. But you have we have some very nice operators like this question mark dot, which will handle that null case. So if this is an extension function, that's why it's possible that this is null. And if it's null, then the right hand side of the expression will not be executed at all, and will stop and return null. So that's a very, very nice way to handle this very common case, and you don't have to pollute your code with if and so on. Okay, I mentioned Java 21 and virtual threads, which are great, but when we do really complicated stuff with, when we really want to do something with concurrency and we create threads, we also need some way to not get lost in it and to have some control, like in the basic programming language, if you know, or in assembly, we have goto, and for some reason people found out that it's not a very good idea to use the goto command that can basically jump anywhere. and that's why we use structures like while or for, where everything is enclosed in some braces and blocks, and it's much easier to reason about that. And something similar happens with concurrency, that when we create threads that can execute in parallel, ideal in most cases we want to be sure that when one of those threads finishes, that the other ones also finish, or they are somehow coordinated, so that we don't forget about some thread that we created, and it will continue executing somewhere in the background and nobody knows what happens actually. So and for that we have something that's called structured concurrency. Unfortunately in Java, still even in the latest Java, it's still in preview, so yeah, we are still waiting for some consistent and reliable way of managing threads. Whereas in Kotlin, from the very start, we have coroutines, which is a structured concurrency construct that is built into the language. So it's if you really want to do a lot of asynchronous and parallel stuff, then with coroutines you really can have it under your control, and the code looks like almost like sequential, like normal single threaded code, but it can be asynchronous and it can be parallel. And there are a lot of other features. Many of them are my favorites, but I don't want to put you to sleep here. So yeah, if you are interested in more, reach for my mini book that I mentioned in the beginning. I will skip over this, but to sum it up, you can still say, okay, this is all nice, but it's just a syntactic sugar. That's a common argument that I can hear, and yeah, that's true. But again, you need to try it, because when you see that there are so many small things, small improvements in the language, together all of these improvements can have a big impact. So I call it syntactic sugar synergy. So suddenly it's very powerful. It's not just bit and bit, but it's like some system that's in a new level, so to say. And yeah, even we can compare it even with Java, because as I said, with new Java versions we get new syntax features. Some of them are even features that are not present in Kotlin, like for example the pattern matching. That's quite an interesting feature in Java. But there's many times we can see something like a vicious circle in the developers and developer teams. New features are coming to Java now every 6 months. There's a new major Java version, but they are coming bit by bit. So yeah, there's a new Java version, and now a typical Java programmer will take a look. Okay, there are some new things, but somehow it doesn't make, I don't know why, because they can't see the big picture. And they say, okay, I've always programmed this way, why should I change something? It's actually safer to use the old syntax, because it will work in Java 8 and it will also work in Java 17, so why should I bother about these improvements? But at some point there will be some major upgrade. Yeah, that's another unfortunate thing, that even though we get the new Java version every 6 months, the reality is that in projects the Java is at least the best. In the best case, usually it's jumps from LTS version to LTS version, so like from Java 11 to 17 now to 21. And then suddenly there are a lot of features actually that are in the difference between these versions, and the Java programmers are unprepared, and now they don't know, okay, what should we do? So again, this can be a source of some confusion, and basically, yeah. The point is, you should care. You should, even if you can't use the new Java features in your current project, you should be aware of them. You should at least have some code katas or some hobby project or something where you learn how to use the new features, so that you're ready when you upgrade to new versions. Because otherwise, it's really, I'm too busy chopping woods to sharpen my axe, so I will continue doing everything inefficiently because I just don't have time, and that's stupid. Now, okay, you may be asking, okay, that's very nice, but changing from one language to another one is a difficult thing to do. And can I do it? How can I do it? When can I do it? Many questions. The good news is that from Java to Kotlin, really the paths are very short and very easy. Really, from the very first design of the Kotlin language, the guys, they were trying to make it as interoperable with Java as possible. So you can take your existing Java classes and invoke them from Kotlin. You can invoke Kotlin classes from Java. You can extend them both ways, even if they are coming from a jar file and you don't have a source code for them. Actually, I could compare it really as we have this situation that we have old code and new code, and old programmers and new programmers. We often have a mix of styles in our Java code bases. So we have maybe some code base that is still in Java 6. And we can have code base, some classes written already with Java 17 or 21 or some new syntax, and it works. Yeah, that's the good, of course, the good trait of Java, that it's backward compatible and in general very compatible. But actually with Kotlin, it's very similar. You can have Java code and Kotlin code in one repository, and it will work. And of course, Kotlin is by JetBrains, and their IntelliJ IDEA helps you in that way that it can automatically convert Java code to Kotlin code. It's maybe not perfect, but it's a very good start. Also, when you're using a framework like Spring Boot, again, when you go to the initializer, you can automatically choose Kotlin and generate the stub for your project in Kotlin. If you're using Gradle, you can use Kotlin even for your Gradle script. And also for the documentation, you can switch between Java and Kotlin, so you don't have to translate it in your mind. You can immediately see how it looks. So really, you can see that many parts of the community take Kotlin seriously. And another objection that you can hear, especially from the managers, that it's easier to get Java developers because of course there are much more of them. But again, that depends on what you want, because maybe if you say in your advertisement that you are hiring, that you want that you're using Kotlin, or that you want somebody who either knows Kotlin or wants to learn Kotlin, it can help you because it can attract the developers who care about the quality of code, or who are willing to learn new things. And that's a very important thing, because in every project you need to learn new things, and you don't have to be, you can't just stay with what you've learned 20 years ago. And you can also attract, for example, Android developers, because of course now for Android development this is like standard to use Kotlin, but some of them may want to become full stack, so that's another opportunity. Then and also if you want to attract maybe younger guys, they may perceive Java as legacy and old, and Kotlin may be more attractive to them. And yeah, you know that Kotlin is basically the same thing as Java, and still, so it can be a win-win. And of course the easiest way is to hire just Java developers and let them learn Kotlin, like it happened to me. And as I said, it's quite easy, and usually you spend more time learning the domain than learning Kotlin if you already know Java. Then of course there are some strategies how you can start small. You don't have to switch everything at once. As I said, okay, you can combine, you can convert class by class, but you don't even need to touch your production code. You can start from test classes, and that's actually a very good corner to start from, because for you will get two benefits at the same time. First, that it's low risk, because you won't touch your production code, and second, because actually in tests it's quite typical that there is a lot of boilerplate code, and if you want to have good test coverage, then you have to motivate the developers to be willing to maintain the tests and to write new tests. And of course, if you give them some tools, something that will help them, then they will be more motivated to do that. For example, in Kotlin you can use these backticks to put any string, to make any string an identifier. So this is useful for the test function names, so that they are readable, human readable. You don't need this display name annotation. Then some more hacks, like for example, in my current project I use a lot of UUIDs, and I want some test UUID. It's long and not very nice. You can create an extension function and just convert a simple number to UUID, and you have a test UUID, and it's much nicer, much more readable. Then okay, that's it basically for the pure backend, which was the title of my talk. But I want to tell you a little bit more. The second reason why I was attracted to Java in the 90s was this claim, write once, run anywhere. Because again, I was able to write one code, and that code worked on Windows. It also worked on Unix or Linux, even if it contained a GUI, and that was a great thing. Again, what run anywhere means has changed a little bit since then, and now if we are doing some front end, we don't use so many desktop applications nowadays, and we write quite a lot of web-based applications with web-based GUIs. Here, this is again Kotlin tries to catch this trend of the new platforms that we have now, and we have this Kotlin multi-platform thing. So you can use Kotlin not just to target a JVM like with Java, but you can compile to other platforms. Of course, Android, but also for iOS, but also JavaScript. That's a little bit deprecated, but you can have WebAssembly as a target, so you can target browsers. You can also, but with WebAssembly, that's not just for browsers actually, because there are also rumors that actually WebAssembly will be also the future for server side, because what you have in a typical Docker container that you run on your backend, you don't for running a service, a backend service, you actually don't need a Linux distribution. What you really need is some runtime that can run your application, your bytecode or whatever. And so maybe one day actually WebAssembly will replace the classical Docker containers. Then also we can still do native server or desktop applications, and all that can contain also the UI, as I said, the Compose UI. That is it originated in Android, but basically these guys, they are trying to port it to all the platforms, so you can use the same way of writing UI also for the other platforms, and that's really cool. And even if you don't do UI, if you generate native code, there are some benchmarks that say that the native code is smaller comparing to the native code that you generate from Java using GraalVM. So it can be interesting, for example, for some embedded systems where you have limited resources. Okay, that's maybe too edgy, but just to mention it. And okay, we have some snacks here, so we are all here full snack developers. But actually I wanted to ask, do we have some full stack developers here? Okay, great. I'm also forced to be one. And the situation is that JavaScript actually started around the same time as Java, and somehow it happened. Okay, at the time in the 90s, when I started with Java, I started writing so-called Java applets. I don't know if if many of you know what applets are. They are not supported anymore, but basically it was a Java code that can run in a browser. Now everything that's on the browser is dominated by JavaScript or TypeScript, and that means well, either you have to have people who understand JavaScript or TypeScript for the front end, and then you need to somebody for the back end, or many teams or organizations actually start preferring the full stack developers, and that's because of the agile way of developing. It's good to be able to deliver the full functionality, including backend and front end. so that you don't have to split it to a front-end task and back-end task, so that you know that now it's done and it's done fully. And so with the JavaScript or TypeScript, you can do it with one language, because we have Node.js, so we can run JavaScript code on the backend. And now the question is, do we all want to start learning TypeScript and preparing ourselves to be such kind of a full stack developers? I don't have anything against TypeScript as a language. What I don't like so much is NPM and node modules and all that build stuff. That's really, I always thought that Java is big, and when you build a Maven project for the first time, that it downloads half of the internet, but actually if you download the node modules for an NPM project, you download, I think, the whole internet. So with Kotlin, we have a chance basically to also move to the UI and to the front end more, and that could be also a chance to somehow have an alternative to this. Okay, and still, okay, even if I didn't convince you at all, you can still continue using Java as you used it before, but at least really pay attention to new Java versions, new Java features, because they really make sense. Like, for example, when I had a small talk about Java 21, I said, okay, the biggest feature is virtual threads, and that's good because you just turn it on and it starts working. You don't need to change anything in your code. But somebody argued actually the syntax changes are the important ones in Java, because if you change the syntax, that means it changes the way you think about the code. And that's an interesting idea, that really we should pay attention to the syntax. It's almost like when you learn some human language, foreign language. In every language, the things are expressed a little bit differently, and then it makes you think a little bit differently, and that's, I think, really interesting. So that's maybe another way how playing with Kotlin can bring you something. Okay, so now it's your turn to start thinking and maybe doing something about this. Here again is the link to get the ebook and to subscribe to some updates from me. Also, if you're interested in the book that I'm writing about integrations, that's also something that I like to generate some content about, and I sent some updates about that. So that's it for my talk, and I don't know if maybe we can try to, if you have any questions, of course I'm ready, or then we can try to play with some code, that demo that I skipped. But yeah, we can do it even with my laptop here if you want.
What do you think in the long run, because Java is now, as you said, releasing way faster, is there really a chance that Kotlin can take over Java?
I don't think so. Well, when Java started, it didn't mean that C++ disappeared, or that I don't know, other languages, even COBOL is still here. So I think Java will never completely disappear. Maybe it will be transformed somehow yeah, we have some new stuff coming. We've been waiting for the Valhalla project and some other stuff that can have quite a big impact on how Java works. Of course, we have the challenges from AI and such stuff. So we can't tell what the future will bring. So I think the most realistic scenario is that they will continue being side by side. Maybe the ratios will somehow change, as I said, showed in the Stack Overflow. Maybe Kotlin will grow more, maybe not. I don't know, but well, I think definitely there will be some mutual inspiration that will continue. That the features that are popular among developers in one language will probably in some form appear in the other one, and sometimes they can be even improved. As I said, we have the pattern matching in Java that we don't have in Kotlin, but we have other features in Kotlin like deconstruction, so-called, that you can take object, like for example that data class, and you can take the individual members from it, and you can do it even with things like collections, for example. So you have an array. I use it, for example, for regular expressions. I have a regular expression in there. I have like four parts that I want to take out from the thing that I parse. So I get an array, and I can write like ABCD equals this array, and now it's automatically assigned to the variables ABCD. So I don't have to use indexes 0, 1, 2, 3. It's much nicer. So yeah, there will definitely be a lot of inspiration, and that's the good thing, I think. And we will also see, maybe it will be also interesting to see if there will be more companies somehow betting on Kotlin and supporting Kotlin. Right now, the biggest players are just JetBrains and Google. We will see. Java, that's a big advantage of Java, that it has much more players. And we have the Eclipse Foundation as well, where it's like vendor neutral, and there are very different companies working together on Java specifications. So yeah, it's great that we have a competition of different things that sometimes they can, but they don't have to compete, they can also cooperate. So that's the point.
Is it somehow quantifiable, that efficiency? Kotlin is more concise, as you say. So, have you read any studies or?
I don't know of any. I don't know of any quantitative researches about that. It's just feeling, and yeah, maybe we could try to but in general, I think these studies are quite difficult, because in an activity like software development, it's very hard to do something in a laboratory settings, because either it's unrealistic, that you are just solving some unrealistic problems, and for realistic problems, of course, you don't have the money to do something with one technology and then the same thing with another technology. I don't know, maybe somebody does something like that, but maybe they're doing it just internally. I know that many companies that I work for have some teams that use Java and some teams that use Kotlin, and but also there I think it's usually not a good idea to try to compare people or teams that you're the better ones and you're the worst ones, because it usually doesn't lead to good results.
I can imagine that when someone like some company switch to Kotlin, then they would be like eager to report, hey, like we have increased productivity by 30% or something.
I haven't tried to search for something like that, but I don't know about that, to be honest. But we could also ask the same question about, for example, Java. Like, if somebody switched from Java 8 to Java 21, did their productivity increase? I don't know if there are such studies. So it's hard, I think, to get such data.
Okay, then thank you.